Now before we get into light, I just want to tell you a few properties of light, okay? First of all, I would like to tell you that light is a transverse wave. Light has a speed which is basically written by c, and it has a value of 3.0 times 10 raised to power 8 meters per second. And this is the fastest speed anything can achieve. So this is basically the fastest. So usually you say, have you you might have basically seen those cartoons, Toy Story, right? Have you guys seen those cartoons?
Yes, sir.
It used to say there was a character named Buzz Lightyear, right? And it used to be, somehow it used to think that he's the fastest, right? Although Lightyear is something, not an exactly the correct term, but basically what they meant was that they wanted to name him Light because he was really fast. That's fine. Okay, that's fine. Okay. Now, light is sort of a wave that can actually can travel in vacuum. See, let me erase this. Now, so first of all, we are going to learn about the reflection of light, and specifically we are going to learn about mirrors. Okay. So first of all, let's look at generally what happens when reflection happens. So if this is a plane area, so the light, incident light, comes here, and when the incident light comes and strikes a point, do you guys know what do we do first?
Draw the normal.
Draw the normal, exactly. So the normal is a line that is perpendicular to the surface, which makes this as the angle I, and we have known that angle I is the angle of incidence. Okay, and this is our normal line. Then how reflection occurs is that basically it reflects back the same at the same angle r, like this. Okay, so this is the reflected light. All right, and this r is the angle of reflection. It is the same thing as we've done in the general wave properties, because always follow the same way. Okay,
Okay, sir.
now the interesting thing here is that even if the surface is irregular, if the surface is irregular, then it does follow the same rules, but this time because the normal changes, so because normal has to be perpendicular, so it basically, light that comes from different points reflects with the normal here would be like this, so it would reflect like this. So basically it causes an it seems like it is irregular, but it follows the same rule. And the rule is, the law is the same, law of reflection is always followed, whether it's irregular or normal reflection. And that is that angle I will always be equal to angle R. That has to be there all the time. Is it clear, everybody? Okay. Now, so what you're going to do today is we're going to do reflection of light on a plane mirror. And basically what I want you to do is, I want you to get a pencil and a ruler, and I want you to follow what I'm doing, because it is very, very important. Okay. They will also ask you to basically do the same thing. So you need to learn how to form an image, and for that you should have a protractor, a ruler, and a pencil. Can you guys please bring it right now? Okay.
Sir, is this going to be in the theory part or the
Yes.
alternate for practical?
Both. Can be in both, okay? Now,
So, what do you need to bring in the exam?
you need to have a protractor, you need to have a ruler, preferably 30 centimeter, and transparent one. And then you need to have a sharp pencil. That's what you need, okay?
Okay, sir. So, for all the paper or only this question?
You will also be needing to do scalar vectors, so yeah, you have to take it within, when you go for the exam, you have to have these things, okay? It's ideal to buy that geometry box, right, which has set squares and a protractor and a scale and, you know, compass and stuff. You should have those, okay, for all the exams. Yeah, except for paper one. Yeah, sometimes you also need protractor in paper one, so it's good to take it. All right, now everybody has it. Should we start then?
Yes, sir.
Okay. So, first of all, make a straight line like this, okay? A vertical line. On top of it, write front and then write back. Oh, that's right, front side and back side. Okay. And then just put like a pattern, just to show that this is the back of the mirror. This is your mirror. Plane mirror means that's straight. Now from a point here, draw an arrow like this. Okay, an arrow, and write object. Okay. Now rest of things I'm going to do it on the scale. Now first of all, you use your scale, and from the head of the arrow, just draw a line. So I'm putting a red line like this. Okay, when you have drawn a line, put your scale to 90 degrees and then draw, oh my god, wait, Your protractor would be different than the digital one that I have, so do not worry. Just make a dotted line like this. This would be your normal, right? So this is the angle we want to measure, and this is angle I, and the arrow like this. So we know that it is the incident wave, right? When you're done till here, please let me know. With your protractor, then measure what this angle is. So basically, I just want to tell you your protractor will be like this. It would be like this, right? And you just need to measure the angle from this side. You can also place the protractor like this. Oh crap. Wait. You can also place the protractor like this if you want to and measure the angle. You want this angle, okay? So please make sure that you do it now. So I'm going to measure this. You might have a different angle, of course, because of your line. It doesn't really matter. So this angle basically is, for me, it is 36 degrees. So I'm going to write 36 degrees. Is it clear?
Yes.
Okay. Then what you're going to do is, you're going to measure the same angle on this side. So you can put the protractor and measure 36 degrees. Your angle, whatever your angle is, don't follow mine because mine would be a bit different, of course, because of my line. And then when you measure this angle as R, which is 36 degrees as well, you just extend this line this way. So this will be your reflected line. Is it clear?
Yes, sir.
Both angles should be the same. If your angle was like 27 or 45, your other angle should also be 45, right? The next thing you're going to do is, now I'm just doing with the different color. You can actually use whatever you like. It's okay. So from the same point where you started, just draw another line at any other point on the mirror. So I'm drawing it right here. Okay. And then what you're going to do is, again, draw a normal line. Anaya, are you following? Anaya? And measure this angle I. Anaya here or no? Where is Anaya? Oh,
She's on in class.
She's not in class. Oh my god. Okay. Never mind. So then you measure this angle. You just make an arrow so you know that this is the line that is coming in. Okay, sorry.
Sure.
Yes. Yes. Okay, you guys were. Somebody was asking a question. Sorry. Somebody was asking a question. Yes?
Yes, sir. Sir, what does the blue line represent again?
Another ray of light. Okay.
So, is it like reflected again?
No. There could be like multiple rays coming from one point.
Okay.
Okay. That image that I've had. Okay, that's lost somewhere. I don't know where it is. Because of the class end. Anyway. So basically, what I was saying, let me just try to do it as quickly as possible now. So basically, what I did was initially I put a line at red line. Let me destroy it quickly. Why wouldn't you draw this? Why? For some reason it's not working. Why? Okay, never mind. Just follow here. So basically, your first line should come here, and then you had to draw a normal line. I'm just assuming values, they might not be exact. This is angle I, whatever that was. And then basically we did it till here, where we drew this reflected ray at this angle R, right? You guys are done till here, right?
Yes, sir.
Then the next thing you're going to do is you're going to make another line starting from the same point but at a different point entirely. It could be another ray, right? And then you can draw a normal, and here it will be I, and measure the same angle and draw a reflected wave, the same angle, okay, like this. So this is going to be R. Is it clear? So two rays, actually you need to draw two rays. Can you quickly do this, please? Okay, is it clear?
Yes, sir.
Then what you're gonna do is you're gonna
So can we draw the blue line from anywhere? Or
yeah.
From the
You
object?
can actually make a line above that. It's okay. Just two similar things, okay? So then what you're gonna do is you're gonna extend these lines, use the ruler to extend them backwards. Okay. And try to make it a dotted line like this. Just extend them backwards. When you extend these backwards, they'll come meet at a point. Okay, do it please.
Done, sir.
Okay.
Sir?
Yes.
is the point where they meet is where the image is formed?
Exactly, that's correct. Okay. So then, where it basically touches where it meets. So this is where you will see basically arrow like this. So this is where the image is going to form. And why is this image forming? Because these rays are coming towards your eye. So your eye thinks that basically rays travel straight. So eye thinks that the image is behind the mirror. Do you understand? Alright, is it clear, everybody? Alright, now, so this calls for some properties of a mirror. So the first property of a mirror is that the image is virtual. Virtual means that it forms behind the screen where nothing exists, right? The screen is not forming on the mirror, it's forming behind the mirror, right? The other thing is that the image is laterally inverted. Laterally inverted means horizontally flipped. Horizontally flipped means that on a mirror, if you see P, the P is going to look like this. If you see C, it is going to look like this. Okay. If you see a word like this, okay, my name, Awais, so it would look like SIAW. Do you understand? Every letter and the word is going to be horizontally flipped. Understood?
Yes, sir.
The third property is that image and the object are same size, are of same size, which means whatever the height of the image is and the width of the image is, that's going to be the same. That's why you see the same arrow. It's just that it's horizontally flipped. You see the image and object on the drawing? It's flipped. And now, fourth one is the distance of image from screen is the same from mirror, sorry, not the screen. Mirror is the same as the distance of object from the mirror. What I mean by this is that if you try to find out this distance from here till here, so this distance t will be equal to this distance t. Do you understand? So these are the 4 properties that you're gonna know and you should know. All right. Let me know if you have a question. Okay.
Right, sir.
Okay, so I guess that would be enough for today. And then we'll tomorrow try to do some experiments to figure out how to prove these 4 properties. Okay? All right. See you then.